Hello everyone, today I am going to show you how to create tornado force using PopVop. So let's move into Houdini. So first of all I am going to create some base for our tornado effect, and for that purpose over here I am going to create one geometry container. I just name it as tornado. I just go inside that, and over here first of all I need to create one grid basically which represent or which will help me to create some points on ground. So for that purpose I just set it to 10 by 10, but I just reduce the row and column segments by 2 by 2 over here. And over here I just create one scatter on which I'm just apply some point count like 500 points over here. So now I need one guideline on which my tornado moves, and which will guide me to create that tornado effect. So for that purpose over here I just create one line, okay, and I just set it to maybe length of 5, and I just increase the segment by 10. Okay, now for tornado effect this line should be moved a little bit over here or here. So for that purpose over here I just apply one transform, and to give a little clear movement or some harmonic movement I just apply over here cos bracket $ff multiply with 2 and multiply with 0.7. okay, I'm not applying anything in y, and in z I just apply one sine $ff into 3 multiply with 0.7. okay, so we need some movement like this. Okay, so now we have these straight lines, but I need a little bend in this particular line because we need a little curvy movement in our tornado. So for that purpose over here I just apply one bend modifier or bend operator you can say, and over here in bend I just apply one value sine $ff into 1.2 multiply with 34. okay, and over here capture direction is 1 0, and I just increase value little bit over here. So now see we get some movement like this. okay, now I need a little more twist over here, so for that purpose I add one more band, and over here I just disable this band and I just add twist over here maybe 120 degree, and over here I just set it to 1 in y and just little more like this. okay, so now we get something like this. okay, now I just resample because right now we have limited points over here, so I just resample this particular stuff. Length 0.1 is okay. Over here I just set it to subdivision, and I just activate this curve view attribute because it's storing unit curve parameters value, so it might possible that it will help me to randomize the stuff. okay, so it is preferable to save this attribute, that is fine. okay, now I need to apply some information, or I need to calculate some information for this curve. So right now this curve store normal information, point in position information and everything, but I need tangent information. So for that purpose I just create one polyframe, and through which I am basically generate this tangent. So I have already that normal, so I just off these things, and for tangent I just name it as tangent. okay, so I just store that attribute. So if you want to see that what is the direction of the tangent, so I just click over here information and I click on this tangent, and over here you can see the direction of tangent like this. So if I just bypass this stuff, so it's a downwards in y basically. okay, so now so we are ready for go into this pop network. So over here I just create one pop network, okay, and I just set my first that scatter point, which will help me to generate points as a first input. This is my second input, as well as I need one more information, and that is basically the point, this last point over here is that. So for that purpose I just create one blast, I just drag it over here, and over here I just select points and I just select 0 and I just delete none selected. So now over here I get this point where my line basically moves. Okay, so I just off this thing, sorry, I just delete this stuff and I just put that stuff as my third input. Okay, so now I'm ready to go inside pop network. So I just go inside my pop network. So over here we get some ready-made stuff over here like pop source, pop object, pop solver and everything. So I just select this pop source, and over here in source use first context geometry. It is preferable because we are already put that first context as my emission points, and over here I just set it to points. So now and I just off this particular stuff. So now as you see over here we get some points onto the surface, and like this right now. Okay, now over here I just come over here in birth, and over here I just increase the emission rate is maybe 10,000, and I just reduce the light expectancy to 100 to 2.8, and over here light variance to 1. Okay, so that is enough for that. Now our main concept is that we are going to create one tornado force using PopVop. Okay, so for that purpose I need to create one PopVop. Okay, and over here we already assign that this input and this input. So we are going to use that particular information into our PopVop. So for that purpose I just select this PopVop, I just come into this input, and over here in input 1 I just assign second context geometry. Okay, and in input 2 I just assign third context geometry. Okay, so we can easily use these two information, or the information that come through this particular channel, we can easily utilize that into our PopVop. So I just go inside this thing. Okay, now for tornado our main concept is that it should be moved towards the center, or the line where we have that line, it should be moved towards that particular stuff. Okay, so see, basically what we are going to do is that we are going to create some forces, like what we need is that first of all it attract towards that particular point where we have that line. Secondary, it should be moved towards that line, as well as it should be rotate towards that particular line. Okay, so we have three forces: one move that attract towards that point, one rotate that closest points or that particles around that line, as well as it should be moved upwards in the line. So we need to create three forces. So first of all, see, for example over here we have this position. Okay, now see, for example I just set my position as my velocities. So let's see what happened with that. Okay, so now if I play this thing, so now see, it just react little opposite. It just throw all the particles from the center. Okay, so what we need to do is that first of all we need to assign that location of that particular point or that particular line, and for that purpose what am I going to do over here is that I'm going to create one point cloud open. Okay, so basically this node opens a point cloud file and search for points around a source position. Okay, so what should be my source? That is my input 1, where we have that line. Okay, now we need some point information, position information, so we should apply this position information over here. Now this, I just press P over here and I just search radius should be 2. Okay, so it just search within that 2 radius from that particular point. Okay, now what we need to do is that over here we can filter some data from these things. So for that purpose we just point cloud filter, and over here we need that position, so I just set position as it is and I just name it as P, and I just alt and drag it over here, and over here we need that tangent information. Okay, and I just name it over here as tangent. Okay, now the thing is that for example we just need to, first of all we need to assign that particular movement towards the center as well as towards that particular point, and that particular point we have that information in our input 2, because we just store that only one point information over here. So I just drag it over here and I just get attribute. Okay, and over here I just call the position information of that particular stuff. Now what am I going to do is that over here I am using one subtract operation. Okay, and I just use this position and I just subtract my that point position, which basically represent the position of my curve. So I just add that information over here. Okay, now I just apply this information as my velocity, and now if you see this thing, see we get something like that. So now we get some force towards from that point, not from the center where our point move, we just get information from there. Okay, now what we need to do is that now we need to move this particular information in the center of this point. Okay, so for that purpose I am going to use this position. Okay, so now I again apply one more subtract. Okay, and over here I use this position information, which basically represent that radius, the point which is in the center, or and the radius of that 2, and I just apply this over here, and now I just apply this difference as my velocity, and now you can see that my points move towards that center. Okay, so now I get one force over here that basically attract all point towards that particular center. Now we need to one more force, that is move my particles in up direction. Okay, and for that purpose I am going to use this tangent. Okay, so now let me apply this tangent as my velocity. Okay, and now as you see over here, okay, so we get some movement in negative direction. Okay, so what we need to do over here is that I just apply one multiply by constant. Okay, and over here I just multiply this value with -1. Okay, so now if you play this thing, so now see we get particles move in up direction. Okay, now we need one more force that will help me to rotate those particles which is basically at the center or the radius within that particular line. Okay, so for that purpose I am going to use cross product. So basically cross product compute cross product between two vectors defined as the vector perpendicular to both input vector. Okay, so now over here we have this position information, we have this tangent information. So what we need to do is that over here I just create one cross product. Now we have this moment which will indicate over here. So I just apply this stuff over here, and we are going to use this tangent. And now for example, I just apply this information as my velocity. And now if you play this stuff, see, we'll get rotation in this particular area. Now it might possible that this cross product will give you some information, maybe some more or some lesser. So I just normalize that information. Okay, so now we have three forces, this one, and this one. So what we need to do is that over here I just need to add those stuff. So this is my first force, this is my second force, and this is my third force. And now I just apply that particular stuff as a velocity. And now if you see over here, we get something like this. Okay, so that is the thing. Now definitely you can play around with some random value, you can apply those stuff over here, but the base concept is this. Now I just come out into this pop, and over here I just apply one pop force, and over here I just apply a value like amplitude to 10. And now if you play this stuff, you will get something like this. Okay, now if you want to rotate in opposite direction, what you need to do is that just come over here, just change the cross product from here to here. Okay, now if you check, we get the rotation in opposite direction. Okay, so that's how we get something like that. Now you can play around with some values, like if you want to apply some maybe attribute create over here, and you can just create one attribute named pt, and over here I just set it to pt num as my value. Over here I just apply some attribute randomize. Okay, so we'll get some color, randomized color over here. Now you can definitely play with those stuff, like you can add some lines, polygon, by group, by attribute should be my ptn, and you will get something like that also. Okay, so this is for now. So hope you like this tutorial. See you soon with another tutorial. Thank you.